Section 3.4 covers polynomial and rational inequalities. We've looked at polynomial and rational equations now and functions, so what we're going to look at now is the inequalities. Now this should be a review from college algebra. If it is not, we may need to back up a little and get more help or go to the math lab in order to get some help. So what we're looking at here then is going to be what degree polynomial. It's an x squared times an x would be an x cubed, and here we see the graph of an x cubed. Remember, with the cubic function the endpoints are going in opposite directions. The leading coefficient is positive, so we see an increasing function. These points right here are the x-intercepts, and they're found by looking at where these factors are equal to 0. This is reviewing graphing polynomial functions. So the degree right here is 2. It's even, so the graph is just going to touch right here at x equals 2 and bounce back, not pass completely through. But right here, because the degree of this factor is odd, the graph is actually going to pass through that point. So what we're looking at here is the graph of this equation that we're looking at these points right here. Now we want to know, where is this inequality that gives us this cubic function less than 0, negative? So where is the function here less than 0? Another way of asking that is, where is the function negative? And when you're looking at the graph, that means you're looking at the y values here. Where's the function? The y value is going to be negative. And it looks like it's going to be everywhere to the left of x equals negative 1. Notice we can take this rational function, and right here at the x-intercepts, we can divide at the x-intercepts this function into intervals. These x-intercepts, by the way, are going to be called critical points. And these critical points are your x-intercepts, and you find those by setting the polynomial equal to 0 and solving for x. Less than 0 means, where is this thing negative? The answer is going to be everything that goes from, the interval that goes from negative infinity to negative 1. How to solve a polynomial inequality algebraically. If this is the inequality, the first thing you want to do is get a 0 on the right-hand side. So that's your first step. Put a 0 on the right-hand side. So in order to do that, I'm going to have to subtract x from both sides. So that's going to give me the polynomial inequality. X to the fourth minus x is greater than 0. Your next step then is to factor the polynomial. That makes it easier to find those critical points. So right here we're going to factor a common factor of x out, and that's going to leave behind what? X cubed minus 1. Will that factor further? This is the difference of 2 cubes. Remember, we can factor that. That's going to factor further into x times x minus 1 times x squared plus x plus 1. And this is going to be an irreducible quadratic factor. It's prime. It won't factor further. Do I need to write down on the notes the formula for factoring sums and differences of cubes, or can you look back at your homework and get it? Write it. Okay, I'll write it. Just recall then that the factoring right here is for sum and difference of cube. If you have a cubed plus or minus b cubed, that will factor into a plus or minus b times a squared minus or plus ab plus b squared. You're going to use this often enough, you might as well try to remember it just like you did the quadratic formula back in the day. The minus is on top of the plus because whatever the order is here, it stays the same in the linear factor, but on the quadratic factor it switches. I'm glad you asked. That's an important thing to notice. That was intentional. It was not an accident. That's why this is a minus right here. This first linear factor is a negative, but on the second quadratic factor, it's a positive. The last one, because it's a square, it's always positive. Remember, squares are always positive, so that's always going to be positive. This sign will be the opposite of whatever this and this are. The next step then, step 3, is to find your critical points. So here our critical points are going to be at x equals 0 and x equals 1. Those are our critical points. After we've identified those, then we want to divide the number line into intervals. Here's our number line. We're going to divide it at x equals 0 and at x equals 1. So right here is x equals 0 and x equals 1. Because this is a number line, it goes from negative infinity to 0. This interval goes from 0 to 1. The next interval goes from 1 to infinity. I set each of these factors equal to 0. This is an irreducible quadratic, meaning it won't factor. It has complex zeros. We set each factor equal to 0 and solve for x. Our next step then is to use test points, whether it's positive or negative, and then you're going to write your answer using interval notation. A test point can be any number that's within this interval. For this first interval, I'm going to test x equals -2 works. And I'm going to go back to where I have this thing factored because it makes the check easier. So this would be -2, that's negative. -2 minus 1 is negative. A negative times a negative is positive. -2 squared is 4, minus 2 is 2, plus 1 is positive. So the whole thing is positive. Go to the next interval. What do you want to test? X equals 1/2. 1/2 is positive. 1/2 minus 1 is negative. 1/2 squared is 1/4, plus 1/2 is positive, positive. So we have a positive times a negative times a positive. The whole thing is negative. Go to the next interval. What do you want to test? You can use a 2 or 2 million. It doesn't matter. It's just got to be a number within that interval. So when we do that, we get positive, positive, and positive. The whole thing is positive. Which intervals did we want for our answer? Positive or negative? Right here means that you want positive intervals. So that's going to be this interval right here and right here. We wanted the positive intervals. So our solution then is going to be the set of numbers between negative infinity and 0, union 1 to infinity. Then you solve this inequality. I'm going to pause the recording and then put the answer up. Okay, check your work. Did y'all get it correct? Good job. You can always go back and review the video if you need to look over this again. It's similar to the example that we did before, but different enough that it presents a bit of a challenge. You can go back and check this, but we do need to move on. Okay, so the next problem is solving a rational inequality using its graph. So that wrapped up the polynomials. Now we're going to move on to rationals. And the only real difference between the rational and the polynomial in the process that we went through with the steps is that now our critical points will come from two places, from the numerator and from the denominator. You still want to begin by getting a 0 on the right-hand side. So if there's anything over here other than 0, you're going to have to use your properties of rational functions in order to get this to be one rational expression and then a 0 right here. So that's the form that you want these to be in. So let me move this down. Let's go ahead and factor this inequality, the terms in the inequality. That's going to give us x plus 2 times x minus 2 over x plus 3 times x minus 3 is greater than or equal to 0. Now here's where the difference comes in. Whenever you find your critical points, they're coming from both the numerator, we get plus or minus 2, and from the denominator, and we get plus or minus 3. Because remember, when we have denominators equal to 0, it's a critical point. The function could change signs. However, those are also asymptotes. At that point, is the function ever going to be equal to 0? What makes a fraction equal to 0? If you have 0 over a number, that's going to be 0. But what if you have a number over 0? That's undefined. So any critical points from the denominator will never be included in your answer. The critical points from the denominator will always get parentheses even if this has a greater than or equal to. Because the only way that a fraction can be equal to 0 is if the numerator is equal to 0. And that's one of those things that I say that I don't write down that it might be in your interest to write down. So we've got our critical points. The next step in the process then is to divide the number line into intervals. I'm going to make a longer number line because we have more critical points. Matter of fact, we end up with 4 critical points. So my first interval is going to go from where to where? Negative infinity to -3. Well, I put parentheses or brackets on the -3. Parenthesis because can't have a 0 in the denominator of a fraction. That critical point of -3 came from the denominator, so we don't get to include it in our answer because the fraction is not equal to 0. at -3. It's undefined. The next interval goes from -3 to parenthesis or a bracket. There we get a bracket because this, when x is equal to -2, we end up with a 0. The fraction right here, the rational expression, is indeed equal to 0. Then we go from -2 to where? To 2. Do I put a parenthesis or a bracket on the 2? Then we go from 2 to where? 3, parenthesis or a bracket. And then we go from 3 to infinity. And parentheses always go on infinities, right? Positive and negative infinities always get parentheses. Our next step in the process then is to find a test point. We're going to test x equals negative what? -4 works. So -4, that's going to give us a negative times a negative is, and a negative times a negative is. So we have a positive over a positive. The whole thing is positive. Then we're going to test what number? X equals -2.5. I like that. -2.5 plus 2 is negative, and this is a negative. So the negative times a negative is, and -2.5 plus 3 is positive, and a negative is negative. The whole thing is negative, because it went positive, positive, negative, positive. I mean, positive, negative. Sorry. Alright, then we're going to test what? I like 0. Makes the arithmetic easy. Well, that's a positive times a negative is negative over a negative is positive. Negative over a negative is positive. Go to the next interval. What do you want to test? 2.5. So that's going to give us positive, 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 negative. The whole thing is negative. Go to the next interval. Test what? 4 or 4 million. It doesn't matter. So this whole thing is going to be positive. And what intervals did we want? We wanted, because this is greater than or equal to 0, we wanted the positives here. So that means that our final answer then is going to be the interval that goes from -infinity to -3 union -2 to 2 union 3 to infinity. And you've got to get the parentheses and brackets right here. It's all wrong if it's part wrong. The bracket means that you can include that number. That's where the function is actually equal to 0. The parentheses are where you include it right up to that point, but that -3 is not in the domain of the function, so how could it be included in your answer? That's a good way of looking at it. These numbers that made the denominator 0 are not even in the domain of the function, so how can they be in the answer? Next problem. What if this isn't a 0 over here? How are we going to handle that? We're going to move it over and make this a 0. So we end up with 4x plus 5 over x plus 2 minus 3 is greater than or equal to 0. You see how I just subtracted 3 from both sides and I got the 0 there. But I need this to be one rational expression. So this minus 3, I'm going to write as minus 3 over 1 so that I can then come along and multiply this fraction by x plus 2 over x plus 2. And I do that to get a common denominator. And I want a common denominator so that I can combine these fractions. So that's going to then give me 4x plus 5 minus 3 times x plus 2 over x plus 2. Now I need to come along and distribute the -3. So when I do that, I get 4x plus 5 minus 3x minus 6 all over x plus 2. Now what? Simplify by combining like terms. So when I do that, I'm going to get 4x minus 3x is x. 5 minus 6 is minus 1 over, this is greater than or equal to 0. So now I just solve like I did all the other problems. How many critical points am I going to have? 2. What are they? We have 1 and -2. Which one goes first? Or this first interval goes from where to where? -infinity to -2, parenthesis or a bracket, because that came from the denominator. And this goes from -2 to 1, parenthesis or a bracket. Good job. And then finally 1 to infinity. Tell me, what are we going to test right here in this first interval? -3 minus 1 is negative over a negative. The whole thing is. Next we can test 0. That's going to give us a negative. And then we can test I don't know, 5. This whole thing's going to be positive. What's our answer going to be? Positive, so we want everything that goes from negative infinity to negative 2, union 1 to infinity. The question was, why did I put this part right here? I did that so that I could get a common denominator, and I needed a common denominator so that I can combine this into one fraction. You don't want to work it until you have one fraction. So I can turn 3 into a fraction by putting it over 1, and then I multiply top and the bottom by the same thing, so that doesn't change the value, it's just changing the appearance. Because what's in red right here is actually has a value of 1, and you can multiply by 1 all day long. You're just manipulating symbols. All right, the last thing then, I've spelled out the steps that you need to use for solving polynomials and rational inequalities. These are also in your notes. You've handwritten them out, so you should be set on this section.